This is question number 28 in S.C. Verma's electric currents. This is a circuit that has one resistance and then two resistors in parallel and finally another resistance. Find the currents of the other three resistors, this. We are given that the current in this resistor, 12 milliampere, flows in 5 kilo ohm resistor. And what are the currents in this and this resistor, and what is the potential difference between point A and B? So let's look at this circuit again. From here, the 12 milliampere current starts flowing through this 5 kilo ohm resistor. And then the current, some part of the current goes into this and the other part goes into this. Let's call it I1 and call it I2. We need to find the values of I1 and I2. Then this current will come here, from here this current will come here, and they will both combine. And when they combine, the sum of these two currents will be the same as this current, 12 milliampere. So the current in this resistor is going to be 12 milliampere. The next part is this, 12 kilo ohm and 10 kilo ohm. Now what governs the ratios of I1 and I2? The total current is 12 milliampere. The current in I2 is going to be a little higher because the resistance is smaller. Now mathematically how we define this? And for this we use one rule, and the rule is the voltage across this point between this and this, let us call it V, is same as between, whether we measure it between this point and this point or between this point and this point are same, because they are same electrical copper connected points. And the voltage on this arm, if we follow this branch, and the voltage in this branch is going to be I2 into 10 kilo ohm. In the same way, voltage between this point and this point, if you follow this branch, then it's going to be I1 into 20 kilo ohm. So V is equal to I1 into 20 kilo ohm is equal to I2 into 10 kilo ohm. In any branch like this, if you have multiple branch and if you have unknown equations, you can use one of the equations as making the voltage equal across the different branches of this thing, especially involving currents. So we have 20 I1 is equal to 10 I2, or 2 I1 is equal to I2. Another thing that you know is the sum of I1 and I2 is nothing but this 12 milliampere from Kirchhoff's current law. So I1 plus I2 is equal to 12 milliampere. I2 is equal to 2 I1. We substitute this here. I1 plus 2 I1 is 3 I1 equal to 12 ampere, or I1 is equal to 12 divided by 3, or 4 milliampere. And then I2 will be double of that. I2 is equal to 8 milliampere. So this solves the current part of this problem. Now for the voltage, we know that the voltage between this point and this point is given by V is equal to I into R. And we know I is 12 milliampere, R is 5 kilo ohm, so it is 60 volt. Then the voltage on this, we can take either this branch or you can take this branch, the upper branch, to find the voltage value. If we know the I2, which is 8 milliampere, so 8 milliampere multiplied by 10 kilo ohm is 80 volt. Just remember this kilo means, for example, in this work, kilo means 10 to the power 3 and milli means 10 to the power minus 3, so they will cancel out. We get 60 and this we get 80. This one is 100 kilo ohm and the current in this one is 12 milliampere. So 100k multiplied by 12 milliampere is going to be 1200 volt. So 60 plus 80 plus 1200 is 1340 volt.